3, 2, 1, contact.
Okay, hello, and welcome to Time for More Math. Did I just say math? It's not chemistry class. Okay, here we go. Is systems of equation. That's our new topic for today. Systems of equations. That sounds really fancy. I know. I teach math and I like to keep it real fancy. Okay? But really, it's not that fancy. What we're doing is we're graphing two lines. We're at the beginning, okay? We're at the beginning of something bigger. So yes, this does go somewhere beyond, but we're not there yet. So systems of equations means that you're going to have two equations to start. We're going to start small, okay? So we learned how to graph a line, and now we're going to graph two lines. And what we're looking for is where they cross, okay? The solution to systems and I put that in quotes because sometimes you're like, what does that mean? Like, we're used to saying solution meaning like x equals 1, or solution is like reduce your carbon emissions, right? But the solution in this situation, where the lines cross.
Can you see it up there? Can you see where the lines cross? No, you can't. Ready? Boop. See, I wrote it up there. Where the lines cross. We'll zoom in later.
So, the solution is where the lines cross. Or as I like to say, where the lines diverge on a whiteboard. Nobody? No? Okay. Hi again. Okay, our last example was a perfect reason of why solving by graphing is imperfect. We are going to revisit that tomorrow when we do systems in other ways, because I like those numbers, but it did frustrate us. So I have another one, and these might also frustrate us, but we'll see. Yeah? I wanted us to practice graphing by intercepts. So this is line 1, and this is line 2. So, graphing by intercepts is that when x, the intercepts, let's remind ourselves what intercepts are while I get dashes on our lines. Intercepts is the word we use in math class. No, it's not like an online news publication. Intercepts are what we use, and it's not when somebody from the opposing team catches the ball. Specifically in math class, we use the word intercept to mean where our line crosses one of the axes. The y-intercept is more famous because it dangles off the end of our equations. When we solve for y, we don't often solve for x, and that actually has to go down to what a function is, right? Since we're not solving for x, we solve for y, the y-intercept becomes more famous, but they both exist. So when you graph by intercepts, what you're saying is, when x equals 0, you set x to be 0, so it doesn't move. So you're going to figure out where your line crosses y. And then you also say when y equals 0, okay? And that means you're going to figure out where your line crosses x because you don't go up or down. So when x is 0, what you're left with is negative 2y equals 6. You see what I did there? This is just gone. It's gone. So we're left with this, in which case y equals negative 3. So that's our intercept here, 0, 1, 2, 3. When y is 0, this part goes away, and you get 3x, or 3x, even though I wrote y, equals 6, in which case x is 2. So that translates to the point, this translates to the point 0, negative 3, this is 2, 0, right? There are the zeros that we've embedded in. So there's that. There is our line number 1. Now, can you guys see line number 2 over there?
I think so. I'm going to pull my Vanna White and
Go on the other side. Intercepts for these are pretty straightforward. When x equals 0, y equals 2, right? Because the x is gone. And when y equals 0, x equals 2. So we're going to have the point 0, 2 and the point 2, 0. Let's go to our graph. Oh, looky there. Where do these lines cross? This is line 2. It sure looks like it's going to cross at 2, 0. Solution. Remember, it's a question, because the last time, yikes, 2, 0. So we need to check it. We need to check that 2, 0 works, and we actually kind of already did, because it's intercepted for both of them. But let's do it in the original, okay? Check. 3 times 2 minus 2 times 0, does that equal 6? Well, 6 minus 0, does that equal 6? Yes. 2 plus 0 equals 2. Is that true? Yes. This checks out. It checks out. It checks out. Solution is 2, 0.
You see all that? Let's zoom. Zoom a zoom. Okay, there we are. Here she is. Our line solution.
It's a little low for me. She's the base. Are we good for today? We're going to graph a few more because there are a couple of things that could happen. We got time. Hey kids, we're back. Or maybe mom and dad. It's okay, if you needed a refresher, I'm totally down with that. This is for parents too, and I'm not even kidding. Please, please, I beg you, don't tell your students, I haven't done math in 30 years. I haven't done math in 20 years. Please don't. I don't know how to do this. Watch these videos and learn. And then help your child. That'd be awesome. Solving America's math problems, one equation at a time. Okay, so here's line 1, line 2. Let's not do by intercepts. Let's solve this one first. Let's graph this one first because we know it, right? Start point 0, 0, right? It's not that there's no intercept, it's that there's no intercept. Which means there's a 0 intercept, which means it's 0. Okay? We need to understand how our colloquial words to say there's nothing there. Nothing means 0 in math class, right? Nothing comes from nothing. So we're starting at 0, 0, right over here, and we move up 3 over 4. Yeah? We'll double check this. Move up 3 over 4. So 1, 2, 3, 1, 2, 3, 4. Or we could go down 3. Right? And we will get our line. No school like the old school. You know what I mean? Okay. Now, we could graph this by intercepts, but let's just solve it for y, okay? Put to slope intercept form, which means to solve for y, yeah? So, 3x minus 4y equals 8. We're going to subtract 3x. I'm going to write this negative 4y equals negative 3x plus 8. Divide by negative 4. Divide by negative 4. Remember, divide everything. Y equals, are we still on the, you still see that? Yes, we're going to zoom in a bit. Negative 3 over negative 4 is 3/4 positive, right? X, let's make this equal sign prettier. Minus 2. Positive 8 divided by negative 2. Let's zoom in just so we get our algebra down. I mean, this is algebra class for Pete's sake, right? So we want to make sure that we get it. Let's zoom this right on in. Okay? Do you see that? We're solving it for, so, starting point, start at 0, negative 2, right? I'm going to go over here. You follow me. You ready to follow me? It's a little jolty. 0, negative 2. Let's go back. Go back over here. How does this move? I gotta clean this up. Moves. Move. What have we got? Up 3 over 4. So let's go do it. Yeah, I know our graph. It's way over there. All right. I'm pushing. So we're gonna move from here up 3, 1, 2, 3 over 4. 1, 2, 3. So these two lines will cross. These lines will cross somewhere is it, do you notice it here? Do you think they'll cross? Where are they going to cross? I don't see anything that's obvious to me. Do you see it? Do you see anything obvious? Should we zoom in on the lines? These lines don't seem to be crossing. Do you see the lines? Okay, I don't see, so if I'm looking at this, right, I'm going to use my pointer. I don't see them crossing this direction, nor do I see them crossing that direction. So, did I do something wrong? Hello. Let's finish this up. Yeah, we had a little interruption. I'm a busy woman. So why are these never going to cross? Because they're not going to. Cat's out of the bag. Okay, they're never going to cross. Why? Because they're parallel with Johnson. I'm sorry, what did you say? Because they're parallel, Miss Johnson. Did you say because they're parallel? Yes. Oh. Yes. It's because they're parallel. That's why they'll never cross. Parallel lines will never cross. Could I have saved myself some time and figured that out before I graphed them? Yes. What? Yes. I think I heard someone say yes. So I'm gonna go by that someone said yes. What did we talk about? Parallel lines. Do you remember that? Something about graphing and equations and slopes of parallel lines. Parallel lines have what kind of slope? Anyone? This time nobody knows, I guess. They have the same slope. So let's look. There's our second line. What's our slope? 3 over 4. What about our other line? We got to scooch-a-dooch a little bit on this one. Oh, there. Whoop, there we are. Once we solved it and got it into slope-intercept form, we could see it more clearly, although we didn't need to. The slope exists no matter what. But what is this slope? 3 over 4. because it starts in different spots, but it's moving the same the whole time, right? That's going to get it to zoom, ding a ding, ding, ding. So that one one of them started at 0, one of them started at -2, okay? But if they're constantly moving in the same way, up 3 over 4, up 3 over 4, down 3 over 4, down 3 over 4, ba-ding, ba-ding, they're always going to remain that far apart. It's called math. Parallel lines have no solution. We still have to answer the question. What's the solution? There isn't one. Number of solutions because they're the same. But most of them will have one solution where they cross. When I order pizza and I give them my address, they say, where on Thomas Avenue is your closest cross street? And I'll say 43rd, right? I live near that cross street. Streets are long. Where did they cross? Helps give us a precise location, okay? Latitude, longitude. All right, so let's graph this first. Let's remind ourselves how to graph from standard form, okay? We have two options from standard form, all right? This is standard form. Graphing, standard form. Option 1, find intercepts. So I'm actually not going to do that for either of these. Option 2 is solve for y, which then gives us slope-intercept form. Okay, so before we get to the graph, I'm going to zoom in a little bit on the equations. Okay, we're super high tech here. All right, ready? Ding, 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 ding. This is theme music. All right. So we need to graph these, but I have to change them. So line 1 will become this. Line 1, 3x plus 2y equals -4. We're solving for y. So we subtract 3x, 2y equals, I'm going to put the x part first, -3x minus 4. Divide by 2. Don't forget to divide everything by 2, okay? Y equals -3 halves x minus 2, okay? That's arithmetic. If you struggle with that, you've got to work on it, right? It's like we're wanting to play like varsity level basketball at this point in time, and if you still struggle to dribble with your left hand, you've got to practice that on your own, okay? We just do it in here with practice. And like the coach is like, go left. And you're like, but I can't go left. I'll be like, practice. Okay? If you struggle with arithmetic, you just got to practice. Okay? So this is line 1. We get line 1. We're good? So I've transferred line 1 into slope-intercept form. You see it there? Now it's in slope-intercept. So right in this space, I'm going to convert line 2. Are you ready? Just like Vanna White, I switch sides. See? Do-do-do-do. Is that the right? No, I don't know. Okay. Line 2, when we convert it, so x plus 3y equals 1. When we subtract x, 3y equals -x plus 1. I'm going to put it that way because it's something we're used to, slope-intercept form. I know we want to put x on the end, but I get to do this. It's the associative property, it doesn't matter. So I'm going to divide by 3. Divide by 3. Oh, fraction. Oh. Oh, fraction. Should we just change this? Let's just change this to a 3. Let's change it to a 6. Why am I changing it to a 6? So that my intercept isn't a fraction. If you see it, you see it. If you don't see it, just accept it. Maybe you'll see it later on. I don't want, for example 1, our intercept to be a fraction, okay? I'm trying to help you out here. We'll fraction this up later, I promise. Y equals negative 1/3 x plus 2. 6 over 3 is 2.
1 over 3 would have been 1/3. That's not very much.
Okay, so we've converted these. Do you see them?
There's line 1, and there's line 2. It's right on the edge. Ding, 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 ding. All right, now we're going to convert. We're going to zip over here. Oops, that's not the thing I want. I want to twist this thing. We're going to go doo-doo, doo-doo. This is super high-tech, 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 high-tech. Okay, here we are. Now we're over here.
I am the cameraman and the teacher. I do tech also.
Above the line, below the line. All right, systems of equations. All right, now we're going to graph them.
I'm going to rewrite them. I'm going to rewrite them right here. Can we see in this corner? Yes, we can. So here's line 1 is y equals negative 3 over 2 x minus 2. And line 2, can we see down here? Barely. Line 2, I'm not going to rewrite it. Y equals negative 1/3 x plus 2. Can we see both of these?
Are we seeing them both? Yes, we are. Boom, boom. Boom, boom.
Okay. So what does this mean? This is like our starting point, okay? So line 1 is red. Let's not mess that up. So start here. That translates to the point 0, negative 2. Because that's what we mean by intercept. Where does it cross the y-axis? 0, negative 2 is here. This is where we're going to start our line. This is where we start everything. It's called the origin, right? So, this is how it moves. How it moves. And it goes down 3 over 2. Okay? So we're going to graph that. We go down 1, 2, 3. There goes my clock. 1, 2, 3 over 2. Or we could also go up 1, 2, 3 over 2. Either way, that's my line. I'm going to graph it in red. Okay? Here's line 1. I had a way more decent line than I thought. Okay? Are we there? Are we see it? Are we seeing it?
Is it exciting yet? Is it super exciting? It totally is. We're going to zoom back down. There we go. Oh, but we need the line there. There's line 1. Okay?
So line 2 I'm going to do in green. Line 2. Start here. Start here. Where is here? 2, aka 0, 2 is the y-intercept. Start the origin, go up 2. I'm doing the line in green, but I'm doing the dots in black. Now, this is how it moves. Moves down 1 over 3. Okay? So we go from here, down 1 over 3. Down 1 over 3. Down 1 over 3. So, that means our line is going to look about like this. Okay, can we see it?
Do you see where they cross? Let's zoom in on that. That's where they cross.
This is the solution. Okay, where they cross is always a solution, but where is that? And how can we be positive that our guess is right? So let's see. This is why eventually we have to have a better way than just graphing. We're going to learn those in different lessons. Okay, today we're solving by graphing. And then we get to do more algebra later, because it's called algebra. Where do we think this is? I think that is about, bing, 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 bing. That looks like about negative 3, 3. I think that's the solution, negative 3, 3. So let's check. And how do we check? Well, let's go back to our lines, okay? We're going to zoom over again. We're going to do very high tech. Ready? And down, and flex, and there are lines. Okay, so there's our lines, line 1 and line 2. Okay, we're going to check it. So what was our solution? Here, we'll go in purple. Here, our solution, negative 3, 3. That's our question. Is this the case? Is this the answer? So let's check down here. What we're going to do is we are going to just simply plug in the answer to both lines, and if we get a true statement, it's a solution, and if we get a false statement, we go, oh man, I'm wrong, and we got to kind of start over. That's why graphing isn't the most perfect. Awesome, we see the solution, but we don't necessarily get the numbers right, so we have to do it by algebra. I'm getting a good workout. Some squats. Okay, so we put negative 3 in for x and 3 in for y, and we ask if it's true. So, does 3 equal, question mark, negative 3 halves, negative 3 minus 2? Is that true? Oops, I already have a question mark. I don't need it twice. So when you check stuff, leave, if you have this the same, here I gotta zoom down now. If you have this, right, you can just leave it. If you have, leave the 3, and then solve that half, and if you get up with something that's equal, then it's right. So the question is 3 equal to, well, negative 3 halves times 3. The negative cancels each other out, okay? And we're gonna get, ooh, this is not true. 9 over 2 minus 2. That can't be true, because we have a fraction. That's not true. Did we not do our movement right? Wait, no, that's right. That's right. Well, let's look over here. So this is not true. No. I don't even have to check the second one because I know I'm wrong. So let's go back and double check our work. Oh, I did the wrong thing again. Blast these blasters. All right, let's go over here again. So our presumption that's 3, 3 is wrong. So let's do a couple more click-throughs, yeah? I think this is actually a fraction. That's what it is. So let's check.